Yo, what's up, Mr. White?
Yo, hello. Yes, I'm Mr. White. This is lesson 8-7. We're now factoring special cases. The Xbox method, which we just were talking about in the last two little sections, has helped us factor both trinomials that have a leading coefficient of 1 and those that do not. In this lesson, we're going to learn how to factor some unusual polynomials to what we call special cases. We're going to use the Xbox method to factor completely. If we look at a polynomial, okay, on number 1, so x squared plus 0x minus 16, we need to remember when we are factoring, we need to factor out the greatest common factor, GCF, if we can. So on the first one, since this is a 1 and we do have a 0, okay, we cannot factor out a number and we cannot factor in an x because the 16 does not have a x value. So what we're going to do, we're going to draw a little x. Okay, remember, we're going to multiply the coefficients 16 times 1. So we're going to get negative 16 on the top. And then we're going to take this b term, this term right here, and we're going to place it right here, which is 0. So what we're doing is we're looking for two numbers that multiply to get negative 16 and add to get 0. And hopefully you're thinking, hey, 4 and negative 4. So in order to factor with the box, we're going to place, remember, the first coefficient, which is a x squared, in that top left. We're going to put the negative 16 down here in the bottom right. Okay, and then the other two we're going to fill in with those new terms that we just found. We're going to make them negative 4x, and we're going to make this positive 4x. Remember, the variables need to stay with those numbers, and we're working with an x. So now we're going to go factor here. We're going to look at what is the common factor in those two. We can take out a x. Okay. If we look at the next two on the bottom, horizontally, okay, remember this first term right here is a negative, so we need to factor out a negative. And then we're going to factor out, if both goes in there, we can say negative 4. If we go up this way, okay, this first term is still positive, we can factor out an x. And if we go up on this right-hand side, we can factor out just a positive 4. So if we put those together, we have x minus 4 times x plus 4. These are our factors that we're looking for. If we double check, we need to multiply out, distribute. Okay, if we distribute, we get x squared. Then we do this plus 4x. We get a minus 4x, and then we get the minus 16. Notice these will cancel, and we get x squared minus 16, which is what we had up here. They just had a 0x. Good job. Let's jump over to number 2. Okay, notice we're going to put the 9x squared here. We're going to put the minus 4. So we need two numbers. So we draw our x. Remember, 9 times negative 4 is negative 36. And we do not have the b term. So this is really 9x squared plus or minus 0x minus 4. So this is a 0. So again, we're looking for two numbers that multiply to get negative 36, but add to get 0. Ding, 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 ding. Negative 6 and positive 6. So we're going to go over and fill in, and we're going to say negative 6x, because that's the variable we're working with. And then positive 6x. When we add those, we get 0x. Okay. Factoring. If I factor up and down, greatest common factor we can take out of is, hopefully you're noticing, a 3x. If we do this side, greatest common factor, not a 3, but a 2. So we can take out a 2. If we go now the green, so horizontal, 9x squared plus 6x, we can take out a, you said it, 3x. And if we look at this negative 6x minus 4, notice the leading coefficient here, right here, is negative, so we need to take out a negative, and the biggest number we can take out is a minus 2. So we write those down now, 3x minus 2 times 3x plus 2. That should give us our answer. If we double check, distribute through here, so we're going to multiply, you get 9x squared. If we distribute over here, we get positive 6x. If we now do the negative 2, we get minus 6x and then minus 4. These go to 0, and we get what we need. All right, jump down to number 6. If we look at number 6, can we take anything out? We have a 4, a 12. Well, 4 goes into 12, but nothing goes into 9. So we cannot factor out anything out. So we draw our x. If we multiply those two coefficients, that 4 and 9, we're going to get 36 again. And then we bring down that 12. So we need two numbers that multiply to get 36, but add to get 12. Okay, if you're stuck, start with 1. Well, 1 and 36, 2 and 13, 3 and 12, 4 and 9, 5 and nothing, 6 and, oh hey, 6 and 6 is 12. So 6 and 6. So we're going to bring down this first one. We're going to put 4x squared. 9 goes in the bottom right. And then we're going to make this 6x and 6x. Whichever way you go, let's go just horizontal again. What goes into both 4x squared and 6x? 2x. What goes into 6x and positive 9? Hopefully you're thinking a positive 3. I ran out of room on top, so let's go down to the bottom. So if we go this way, we can bring out a 2x, and then we can bring out another positive 3. So if we put these together, we get 2x plus 3 on that vertical side over here, and we get a 2x plus 3 on the bottom. So this should be our answer. If we double check, multiply these, distribute through, we get 4x squared. We get a plus 6x. We get another plus 6x, and then we get this 9. 6x plus 6x is 12x. All right, we're going to hit pause now on 3, 4, and 5. Check back in a couple minutes. Go. All right, welcome back. Check out 3. You should have gotten x plus 2 times x plus 2, which actually we can write x plus 2 squared. Number 4, you should have gotten x minus 5 times x minus 5, which is again really x minus 5 squared. And number 5, you should have gotten 5x minus 1 times 5x plus 1. Hey, make sure you have the box method. Make sure you show your work. Make sure you multiply to check your answer, like I did in 5 right here and all the other ones. Good job. All right, let's jump down to 7. Word problem. The area of a square is 4x squared plus 20x plus 25. So here's our square, just broken up into 4 parts. We can think of it as this way. 4x squared, here's our 25, and then this other part adds up to 20x's. We need to figure out how long is each side of the square. Because it's a square, x squared equals area. Remember, the sides are the same. So when we do this, we got to think both lengths are going to be equal. So let's use the method we've been using. We're going to take 4 times 25 and get 100. We're going to bring down this 20. So we need to figure out what times what equals 100, but adds to get 20. Hopefully you understand. It's a square. It's probably the same. Yes. 10 plus 10 is 20. 10 times 10 is 100. So we're going to make this 10x, and we're going to make this 10x. Now we look to factor out, if you remember. Let's use green. So green sideways, we can pull out a 4 doesn't go to 10, so 2. We can make this a 2x. And 10 doesn't go to 25, but there's a 5 that goes in. So we have that 2x plus 5. If we go up, we can just take out a 5. And if we go up, we can take out a 2x. So we have 2x plus 5, and we have 2x plus 5. Those are both the same. So if we just check, distribute through each, you should get 4x squared. Then we get a plus 10x plus 10x, and then we have 5 times 5, which is 25. 10x plus 10x is our 20x. We get that middle term. Okay, hit pause one more time. Okay, try number 8. Go. All right, welcome back. Number 8. Again, when we had the area of a square, 9y squared minus 6y plus 1, when we factor those out, you get both sides equal to 3y minus 1. All right, flip over the page. All right, the rest of them, we're going to do a couple and then turn you loose. We need to factor. Remember, look for common factors first. Okay, so for instance, number 11. If we look at this problem, don't get scared. It's only 2 variables, x and a y. But you notice, x, y, and then there's a y. There's a y in each term. Okay? There isn't any numbers because the first one's a 1 and a 4 and a 4, so we can't take out any numbers, but we can factor out a y. So if we take a y out from each monomial, we're left with x squared plus 4x plus 4. So right now we have y times x squared plus 4x plus 4. Okay, let's hold on to this y right here for a minute. Let's try and factor this polynomial right there, the x squared plus 4x plus 4. So we stick again, based on what we're doing, x squared on the top left, 4 on the right. We're going to multiply that 1 times the 4 to get the 4. Put the 4 in the middle. What times what equals 4, but adds to get 4? 2 and 2. So we know this has to be 2x, and this has to be 2x. So when we factor out, if we go up, we're going to factor out just an x. We're going to factor out a 2. When we go to the left, we can take out just an x again and just a 2. So we get x plus 2 times x plus 2. But remember, this y was originally here, so we do have a y. So another way we can write this is y times x plus 2 squared. Just multiplying just to make sure. If we go back to this original, the x's times the x's gives us x squared. 2x. If we do the middle, you do 2x, and then we get 4. But we have still that y. So there's a y times x squared gives us the x squared y. We have 4x in the middle times y gives us 4xy, and then the 4y, which is what we originally had. Okay, let's do number 12. Okay, what can we take out? We have a 200, we have an 80, and we have an 8. What can we do? Well, we know this is 10 times 2, 2 times 5 times 2 times 5 times 2. We have 2 times 2 times 2, which is 8 times 10. And then we have 2 times 2 times 2. So right now it looks like we have 1, 2, 3. We have 3, and we have 3. We can take out an 8 for each part. And then if you notice, we have 4 z's here, 3 z's, and 2 z's. We can take out at least 2 z's from each part. So our greatest common factor is 8z squared. What's the polynomial we have left? Well, we have this 5 times 5, which is 25z squared. We're left with 2 times 5, which is 10. So this is 10z. And then on the far right, we have just a 1 if we took an 8z squared out. Leave this 8z squared alone. Can we do this polynomial? Let's put it back in the box method. 25z squared. Put a 1. We got to think. What times what equals 25? Because 1 times 25. And then bring down the 10. We should have 5 plus 5 is 10. 5 times 5 is 25. So we're going to put a 5z this time, 5z, okay, and then try and factor. Okay, if we go to the left, we know we could take out a 5z. If we go to the left on the bottom, nothing to take out, so we always just take out a 1. If we go up, we can take out a 5z, and again we can take out a 1. So we get 5z plus 1 times 5z plus 1. Don't forget about this now, 8z. So our answer, when we put it all together, is 8z squared times 5z plus 1. And we have 2 of those. There's our factored polynomial. All right, let's do one more. Number 14. Again, what can we factor out? Well, right now there is a 1 coefficient here. So because there's a 1, there really isn't anything we can take out other than a 1. So we can't do any numbers. But there's 4y's, 3y's, and 2y's. We can take out a y squared. If you take out a y squared, we're left with 4y's takes away 2, so we're left with 2y's minus the 12y plus the 3. Okay? Let's hold on to this y squared for a minute. We'll put it down here. And then let's plug in. So we have our x box. We're going to go 1 times 3 and then bring down that negative 12. So we have a y squared. We have a 3. We're trying to find these two terms. What times what equals 3, but adds to get negative 12? 3, small number. 1 and 3, 3 and 1. Can I get anything that multiplies it and adds to get negative 12, but multiplies to get 3? No. So I really can't factor this. Okay? Or I can't factor it actually anymore. So the actual factored polynomial is just taking that y squared out, and then we're left with y squared minus 12y plus 3. So we're not talking about no solution. We're not solving. We're just factoring the polynomial. The only thing we could factor out is the y squared. So we stop right there. Y squared times y squared minus 12y plus 3. All right, your turn. We're going to hit pause. You're going to finish. So we got to do 9, 10, 13, 15, 16. Go. Alright, welcome back. Be sure to check your answers. Make sure you're not just copying down the answers. Make sure you're showing all the work through the box method, drawing your X, double checking your answers by multiplying. Check out 9 and 10. Hey, there's 13, 15, and 16. Hey, congratulations. Do your best, forget the rest. We'll check you later. Bye-bye.